In this video, I am going to solve this quadratic equation using the quadratic formula. Before solving the quadratic equation, let me remind you the fact that an equation is a quadratic equation if the highest power of the unknown, in our case highest power of x is 2, like here, with the condition that a is not equal to 0. So a quadratic equation will have this structure: ax squared plus bx plus c is equal to 0, with the condition that the coefficient of the square term is not equal to 0. Now what we need to do, we need to take our given equation, which is this 3x squared plus 4x plus 7 is equal to 0, and find a, b and c, and then plug those values into this equation. Now in this problem, a is the coefficient of the square term, which is 3, b is the coefficient of the x term, which is 4, and c is the constant term, which is 7. Now I am going to take these values a, b and c, and I'll plug it into this formula. So my x is going to be equal to negative b is 4, so it's going to be negative 4, plus or minus square root of b square minus 4ac. b square is going to be 4 square minus 4 times a is 3 times c is 7. So a is 3 and c is 7. So I just plug in these values right here in this formula. Now divided by 2 times a, and then my a is 3 right here, so it's going to be 2 times 3. Now I just need to simplify this thing, this formula. In the denominator, 2 times 3 is 6. In the numerator is going to be negative 4, which is this number, plus or minus square root of 4 square is 16 minus 4 times 3 is 12, 12 times 7 is 84. So it's going to be minus 84. Now if I simplify it further, I'm going to get 6 in the denominator minus 4 plus or minus square root of 16 minus 84 is negative 68. And we can simplify it further. Now please note that I could simplify it to as follows: negative 4 plus or minus square root of negative 68 is going to be, I am going to rewrite it as square root of 68 times negative 1, and then the whole thing is divided by 6. Then I'll continue simplifying it. In the denominator I have the 6, in the numerator I have negative 4 plus or minus square root of 68 times square root of negative 1. How can I do that? Remember the formula that says square root of a times b is equal to square root of a times square root of b, or in general nth root of a times b is going to be nth root of a times nth root of b. I have used this property of radicals to simplify this to this. Now then we are going to simplify it further. So negative 4 plus or minus square root of 68 times. Now remember the definition of imaginary number I is equal to square root of negative 1. That's what we define I to be. So my square root of negative 1 is going to be just I, then divided by 6. So I just found two solutions for the given equation. So for this equation I found two solutions. One is x is equal to negative 4 plus square root of 68 I over 6. I'm going to break it down slightly further. It's going to be negative 4 over 6 plus square root of 68 over 6I, and the other one is going to be just the conjugate of that. So it's going to be negative 4 minus square root of 68I over 6, which is the same as negative 4 over 6 minus square root of 68 over 6i. And do keep in mind, these two numbers that I found, they are conjugates of each other. So it's like, if this is my a plus bi, this is a minus bi. So when you get excuse me, when you get solutions to a quadratic equation that are complex numbers, they come in pairs, meaning they are conjugates of each other. So remember the definition of a complex number. By the way, this a and this a are not the same, just to remind you. So if you have a complex number of this structure, a plus ib or bi, then the complex conjugate of this number is going to be a minus bi. That means you just change the sign in front of the imaginary part. In a complex number, this number is called the real part, and this number with I is called the imaginary part. All you need to do is change the sign in front of the imaginary part of a complex number to get the conjugate. So in a quadratic equation, if the solutions are complex numbers, they are complex conjugates of each other. I hope that this discussion was helpful. Thank you very much.